Okay, this is Integrated Math 3. It's lesson 2.04. And the lesson is on zeros, roots, solutions, x-intercepts. And all those terms mean the same thing. So let's talk about what it means by a zero. Generally in this class we call them zeros or roots. If we take an equation, a quadratic here, and if we were to factor that equation, we would get x plus 1 times x plus 3. Okay, and that would be the factored form, and we did that. We did that in lesson 2.02. But what a zero does, it takes it one step further. It asks what values of x will make this go to 0. Okay, so you simply take this factored form and you set it equal to 0. So the answer is, if this term becomes 0, then the entire equation becomes 0. It doesn't matter what this term is. And if this term becomes 0, the entire equation becomes 0. So it doesn't matter what this term would be. So we're going to find what makes x go to 0. And the way you can simply do that is come over here and say x plus 1 equals 0. I subtract 1 from both sides, and I get x equals negative 1. So if x equals negative 1, negative 1 plus 1 would be 0. So if this became 0, it doesn't matter what this is. Well, if it was negative 1, it would be negative 1 plus 3 would be 2. This would be 2. So 0 times 2 is going to be 0. I could do the same thing and determine that if x equals negative 3 for this one, negative 3 plus 3 would be 0. So if this is 0, and if this were negative 3 plus 1 would be negative 2, so negative 2 times 0 would be 0. So, in other words, if this is 0, if x is negative 1, or x is negative 3, then this entire equation would be 0. Okay? One way you can prove that is you can go ahead and set this equation, because this is the same equation as that, equal to 0. Negative 1 squared is 1, plus 4 times negative 1 is negative 4, so 1 minus 4 is negative 3. Negative 3 plus 3 is 0, so that's true. And if I did the same for negative 3, I'd get also 0. So these are called zeros. So what is a zero? For a quadratic, an equation can always have as many zeros as the exponent of the biggest term, the biggest exponent. So in this case, a 2. So that's a degree 2 polynomial. So it could have up to 2 zeros. And what they are, this is actually the most descriptive term, is their x-intercepts. If you remember what the shape of a quadratic is, it's this. If we draw a graph of a quadratic, it looks like this, like a smiley face. And so the zeros are the x-intercepts. It's this point right here or this point right here. Now it's also possible for a quadratic to have fewer than 2 intercepts. It can have no more than 2 because that's the biggest exponent. But if I drew it like this, so it just touched the x-axis and came back up, there it has, that one has 1 intercept. And if I drew it up here, so it never touched the x-axis, that has 0 intercepts. So it can't have any more than 2 intercepts for a quadratic. If it's an x to the third equation, and I'll show you one of those when we get to one, then it can have 3 intercepts. All right? Why these are important, I'm not going to discuss right now. I'll mention some applications in class, but I want to just get you through the problems here, okay? So what we're going to do here is we're going to start with this one. It says, we can find zeros without graphing at all by writing the equation. Okay, so I just showed you how to do it with that example. So here's one, so we're going to factor this. So how do we factor this? Well, if it's not obvious, if you can do it just off the top of your head, great. If you can't, you take the x to the third, and that's equal to x times x times x. And here is just an x, so I put that here. So this is the x to the third term, and this is the x term right here. So they have an x in common. So that means an x can be factored out of this. So it's going to be x goes out of the parenthesis, and then this term has 2 x's left inside, x times x, so that's x squared. And this one doesn't have anything. Now that can be tricky sometimes. that doesn't mean it's 0, it means it's minus 1. And the way you can check is just go back. X times x squared is x to the third, and x times negative 1 is negative x. So this is the factored form. In lesson 2.02, that's all we wanted to know, was what's the factored form. Now, actually, it factors further. And this right here can be factored. See if you remember what that was. If you go back, there's something called the difference of squares. If you have two perfect squares, x squared is a perfect square, it's x squared, and 1 is a perfect square, it's 1 squared. So if you have the difference of two perfect squares, like a squared minus b squared, then that's going to equal a plus b times a minus b. Okay, and I'll prove that to you here. A times a is a squared. A times negative b or minus b is minus ab. B times a is plus ab. And b times b, negative b, is negative b squared. Okay, so positive ab minus ab, these two cancel out. And all you have left is a squared minus b squared, which is what we started with. Okay, so this equals this. So you got to figure out what's your a and what's your b here. Well, the a is going to be, that's its sideways equal sign, it's going to be x. And the b, whoops, that's going to be the a rather. That's going to be, well, I take it back. That is going to be the x. So the a in this is going to be the x. And the b in this is going to be 1. Okay? So that's an equal sign. All right. So what we can do is write this, just this part alone, is x plus 1 times x minus 1. A plus b times a minus b. Okay, so this one is the a, this one is the b. All right, and then we still have this. Don't forget this. So that x goes there. So there, this is fully factored. This is fully factors to that. Now, we want to know what the zeros are, what the x-intercepts or roots are. So you set the equation equal to 0. And you simply ask what we asked up here. What value of this would be 0, so that if you multiplied it by this and this, no matter what these two were, it would all go to 0. Well, that one's simple. It's 0, if x equals 0. So that's one of the zeros for this equation. What about this? What would make this term go to 0? Well, if it's negative 1, just like the example up there, negative 1 plus 1 is 0, so if this goes to 0, the entire equation goes to 0. So negative 1 is another 0, or solution or root of this. What about this one? What makes this go to 0? Well, 1 would. 1 minus 1 would be 0. So if this becomes 0, everything in the equation becomes 0. I mean, the entire equation becomes 0. So that one would be a 1. So that's the final answer of what the question's looking for. The roots or solutions or zeros for this are 0, negative 1, and positive 1. Okay? And that's the answer to that. Okay, let's do another. Okay, so we have to fully factor this just like lesson 2.02. So some of you may be able to see that 6 factors out of all of these. It goes into 6 one time, it goes into 12 2 times, it goes into 48 8 times. But what if you couldn't see that? Then what you can do is let's go remember how to do this, a factor tree. So I'm going to come way over here. So 6 can factor into 2 times 3. And those are prime numbers, so that's fully factored. 12 can factor into 3 times 4, and then 4 can factor into 2 times 2. So these are all the prime factors, meaning they're factors that are prime numbers for 12. 48 is going to be a little busier here. 48 can factor into, you can pick any two numbers that multiply to 48, and there's several options for that. I'm just going to go ahead and pick 4 times 12. 4 can factor into 2 times 2. 12 can factor into 3 times 4, and 4 can factor into 2 times 2. So what you do is you're always looking for the bottom of the branches here, okay? So that's not a bottom of a branch because it breaks into that. So it's going to be this, that. Okay, so 2 times 2 times 2 times 2 times 3. 4 2's times 3. Okay, so what we do now is line these up. So for 6, I'm going to put it at 2 times 3. That's these two. For 12, it's going to be 2 times 2 times 3. So I'm going to put a 2 there, times 2 there, times 3. And for 48, it's going to be 2 times 2 times 2 times 2 times 3. Okay, this one I didn't do very well, so let me try this again, because I want them to line up so you can see clearly. There's more space here. Let me write it first. 2 times 3. Okay. And then this one is good, this one's good, this one needs another 2, and this one needs 2 times 2 times 2. It's got a bunch of them, okay? So this one's 48, this one's 12, this one's 6. So what do they have in common? They all have a 3 in common, and they all have a 2 in common. These two have another 2 in common, but this one doesn't, so you can't go any further than that. So what do they have in common? 2 times 3, so they all have a 6 in common. 2 times 3 is 6, so that means what can factor out of this is a 6. Okay, so I'm going to go ahead and do that. So it's 6. Okay. Now, what about the x's? So here you have x to the 4th, x to the 3rd, and x to the 2nd. So I'm going to come down here. X to the 4th is x times x times x times x. X to the 3rd is x times x times x. In other words, just break them up. Spread them out so you can see what makes up that. And x squared is x times x. So what do these have in common? They have an x here and they have an x here. All three of them have to have it. So that's going to be x times x is x squared. Okay? So it's going to be 6x squared is what you can factor out of this. Now we determine what you leave inside. Well, for the first one here, the x to the 4th, you leave a couple of x's, an x squared. Or another way to do it is just 6x squared times what gives you 6x to the 4th. Well, you've already got the 6. You got an x squared, you need to get to x to the 4th, so that's an x squared. Now the next one. 6x squared times what gives you 12x to the 3rd. So 6 times what number gives you 12? That would be 2. So 6 times 2 gives you 12. And x squared times what gives you x to the 3rd? You would need another x. So I'm going to put x right there. And then finally, minus 48x, so it's negative. So 6 times what gives you 48? And the answer is, if you're not sure, just go on your calculator and divide 48 by 6 and you'll come up with 8. So 6 times 8 gives you 48, and there's x squared there, and you've already got x squared there, so you don't need to add any more x's. So there it is right there. Okay? All right. So the next thing we do is see if this factors. And you don't know if it does, so you just give it a try. So this is just a quadratic. So what we need to do is the coefficient of this is a 1. So you multiply 1 times 8, that's called the grand product, and that equals 8. So you need two numbers that are going to multiply to 8, actually negative 8, negative 8, and they have to add to this middle number, which is positive 2. So they have to multiply to 8 to negative 8, and I should have actually done a better job on that. Multiply to negative 8 and add to 2, and then the line goes down there. Okay. So I always start with if they multiply to negative 8, they have to one has to be negative and one has to be positive if they multiply to a negative number. If they add to a positive number, which they do, they add to positive 2, then the bigger of the two has to be the positive number. So I'm going to start with the smallest negative and the largest positive number I can. That's -1 times 8 equals -8. Now I'm going to add them. They have to add to this. -1 plus 8 equals 7. So that doesn't work. It doesn't add to 2. Let's go to the next biggest negative number, and that's -2 times 4, +4. That multiplies to -8, and -2 plus 4 equals +2. That's what we were looking for. So these are the two numbers, -2 and 4. I'm going to come over here and just create some space for myself here. So this is going to factor into x minus 2 times x plus 4. Okay. And this can this is what we got out of that, so this is going to go out in front, 6x squared. So now we're going to set this equal to 0. So what does this have to be? What does x have to be to make this be 0? What number would make this be 0? Because if this is 0, then it doesn't matter what these are, it's going to multiply it through to be 0, and you're going to end up with 0. Well, the answer to this is easy. It's 0. 0 squared times 6 is 0, so that's 0. What about this one? What makes this term 0? Well, if it's a 2, 2 minus 2 is 0, that would go to 0, this term, so everything, the entire equation would go to 0, so that's going to be 2. What would make this term go to 0? -4. -4 plus 4 would be 0, so this term would go to 0. That means the entire equation would go to 0. If any one of these things, they don't all have to be true, just one of them has to be true, so that's -4. So x equals this or this or this. It's one of these. Okay? And that's your final answer. Those are your zeros. If you want to test it, you can come back up here and plug any one of these into the original equation. If you plug a 0 in for all these x's, that's clearly going to be 0. If you plug a 2 in, though, 2 to the 4th is 16 times 6 is 96. 2 to the 3rd is, anyway, those two numbers, big to do in my head, so I'm not going to do it. But if you plug any one of these three numbers in for x, you'd find that this equation would go to 0. Okay? So that's how you do that. Okay, let's keep going. Okay, let's move on to number 3. Now, this was the one I had a little issue with in class, and I had forgotten that there was a typo in this problem. This should be a negative sign. So I'm going to make that a negative sign, okay? So it won't work otherwise. All right, so that should be a minus. So just start off the problem right away correcting that, making that plus sign and minus sign. Okay, so now this is factoring by grouping. So what you're going to do is group these two terms, and you're going to group these two terms. Okay? And the way you know this will work is it's got to be a x to the 3rd, a cubic, and then a square, and then x to the 1st, then no term, a constant. And then the ratio of this number to this number, that would be 3 to 2, is the same as the ratio of 27 to 18. If you put 27 over 18 and reduced it down, it would be 3 to 2, 3 over 2. Put this over this, it would be 3 over 2. Put this over this and reduced it down, it would be 3 over 2. Okay, so that they have the same ratio, so that means this method will work. Guys, I don't know when in the real world you would ever do this, but we're doing it now, okay? You won't have to do it forever. Okay, so what can we factor out of this? Well, that's a 2 and that's a 3. They don't divide evenly into each other, so you can't factor either of these numbers out. What you have here is an x to the 3rd and an x squared. So remember that x to the 3rd is x times x times x, and x squared is x times x. So they both have an x in common and another x in common, so that's x squared. So you can pull an x squared out. So we're going to pull an x squared out of here, and that's going to leave us with 2x, because x squared times 2x will give us 2x to the 3rd. And then over here we just have a minus 3, because x squared times -3 will give us -3x squared. So that's completely factored. Now we're going to come over here, and we're going to put that minus sign there. And what can we factor out of this? Well, we can factor, an 18 doesn't go into 27, but 9 goes into 18 and 9 goes into 27. You want to find not only a number that goes into both of them, but the biggest number that will go into both of them. So 9 goes into this, 9 goes into that. So you're going to pull a 9 out. Now this one doesn't have an X, so you can't pull any X's out. So the only thing you can pull out is that 9. So to make this 18X, we're going to make this 2X. And to make this 27, we pulled a 9 out. We're going to make this minus 3. Okay? And what we needed to make this work, and the reason the problem wouldn't work before in class, is because these two terms have to be the same for this method to work. Okay, so now what we're going to do is we're going to put square brackets around this just so they don't get confused. You don't have too many parentheses all over the place. So you can think of this as being a term and this as being a term. And what they have in common is 2x minus 3. So that means you can pull a 2x minus 3 outside of the square brackets out here. So I'm going to go ahead and do that. 2x minus 3, and I'll keep it in parentheses, and then the square bracket, and then what got left behind is x squared, and this, minus 9. Okay? So, can you factor this any further? Think about it. X squared is a perfect square, and 9 is a perfect square. So again, we have a difference of squares. A squared minus b squared equals a plus b times a minus b. So what is a and b? This is kind of, I didn't really show you on the last one how do you figure out. Put a parenthesis here and put a square. Put a minus sign and put another parenthesis and put a square. Okay, so what do we have to put in there so when you square it you get x squared? Well, that one's easy, it's x. What do we have to put in there so when you square it you get 9? That one will be 3. So that's the a and that's the b. I didn't really explain that on the last problem. So that means that a squared minus b squared, I'll come over here, is going to be x, or the a plus b, x plus 3, because this is your a and this is your b, x plus 3 times x minus 3, a minus b, is the fully factored form of this. And then we still have this, so I'm going to put this, it doesn't matter that I put it over on the other side, that's okay. 2x minus 3. So this is fully factored to that, okay? But we're not done. We've got to set it equal to 0. All right, so simply asking, what makes this term by itself go to 0? I think you can all look at that and see it's going to be negative 3. Negative 3 plus 3 would be 0. So that one's going to be negative 3. Okay, this one's even easier. What's going to make this go to 0? If x equals what? That's going to be x equals 3. Now this one's a little tricky, not quite as obvious. So how do you figure this out? Well, it's not that hard. You just create an equation. You're trying to find out what makes it go to 0, so you just create an equation like that. And now we're going to just solve it. So we're going to add 3 to both sides. That cancels. And you end up with 2x equals 0 plus 3 is 3. Now you're going to divide both sides by 2. This cancels. And you end up with x equals 3 halves. So 2 times 3 halves minus 3 will equal 0. Okay, so this one's going to be 3 halves. So here are your answers right there. Let me write it a little more clearly down here. X equals negative 3. Doesn't matter what order you put them in. Positive 3 and positive 3 over 2. That's your final answer for this. Those are the ones. So if you plug any of these 3 numbers, negative 3, positive 3, or 3 halves, into this equation, this big messy equation, it would make it go to 0. It would end up being 0. Okay? All right, let's keep going. All right, number 5. I'm doing them all for you today, guys. So, but I want to be sure you know how to do them. So find a factor each and find the zeros. Okay. So they're telling you that x equals 2 is one of the zeros. All right. And we have to factor them. So how do we do this? 1 0 has been given. So how do we do that? Well, you've got to find all the factors and then turn them into zeros like we did previously, right? We found the factors here, here, and here, and then we figured out what the zeros are. Well, they gave us one of the zeros here, but they didn't give us any more, or they didn't give us any other factors. So what we're going to do first is find the factors. So what's the factor that would make 2 a 0? Think about it. Remember what we said. We said it's something, it's going to make, it's the number that makes, well, let me just show you what it is and then explain it. X minus 2. The number that makes this factor, this binomial, go to 0 is 2. So if this is the 0, then this is the factor that belongs to that 0. Think about that for a sec, because that might not be obvious at first. I'm just working backwards from what we did on the previous problem. If we had had this as one of our factors and we said, what makes this go to 0? You would have said 2. 2 will make this go to 0. So if they tell you that 2 is the 0, then they're going to work backwards and say, what's the factor that this is the 0 of? It would be this. So that's one of the factors, is x minus 2, because this makes this go to 0. Okay, so big deal. What does that help us? Well, what it does is now we can use synthetic division to figure out what the other factors are. So what do we do with synthetic division, okay? You can divide this into this, and remember, you can do it 2 ways. You can do it the big old long way, which is messy, or you can do it the synthetic way. And remember what we did. If we're dividing this into this, remember what we did? We took this number and we flipped the sign. So the number we're looking for then is actually this number right here. It's actually 2. Okay, again, that's just what we did back when we did synthetic division. So I'm going to put the 2 here, and I'm going to do synthetic division of this. So it's 5x to the third, so that's a 5. 4x squared, that's a 4. Negative 20. And negative 16. Okay? And now it's a plus. Remember, you're going to add this. So the first one you pull down. Again, this is going back to lesson 2.03, the last lesson before this one. So you pull the 5 straight down. Now it's 2 times 5 is 10. Now you add, that's what the addition is. All these are additions. 4 plus 10 is 14. 2 times 14 is 28. Negative 20 plus 28 is 8. 2 times 8 is 16. Negative 16 plus 16 is 0. Remember, when you do synthetic division, that last term is the remainder. So there is no remainder. And what that means is this does divide evenly into this. This right here does divide evenly into that. So what we have now is this equation, 5. And since this was x to the third, you always go down 1 power. So it's 5, instead of x to the third, it's x squared. So it's 5x squared plus 14x plus 8. So that is this after you divided this in. So now what you can do is this goes out here. I tell you what, I'm not going to do that yet. That'll just confuse the issue. So let's just take this, okay? We'll deal with that at the end. So now we're going to see if this factors, all right? So we factor this. So what we do is we take the grand product. That's these two numbers multiplied together. It's 5 times 8. So now what you need to do is you need to find a number that multiplies, two numbers that multiply to 40, and they add up to this middle number, which is 14. Okay, so we're going to factor this. Okay, so they both multiply to a positive number and they both add to a positive number, so they both have to be positive. So let's start with the smallest and biggest number. 1 times 40 equals 40, and 1 plus 40 equals 41. Okay, that can't be it. We're trying to find 14. Next, 2 times 20 equals 40. That's good. And 2 plus 20 equals 22. That's no good. We need to have 14. 3 doesn't go into 40, so we can skip it. 4 times 10 equals 40, and 4 plus 10 equals 14. That's the one we're looking for. So that means the two numbers we're looking for are 4 and 10. Now remember, when you have an a coefficient in front of the x squared term that's not a 1, it adds one additional step to it, okay? So what you do is you take the 5 and the x, not 5x squared, just 5 and x. We come over here and we write 5x over this number. And then we write 5x again over this number. And then we reduce, and then we turn this into a binomial. So 5 over 4 doesn't reduce. You can't reduce it. So the first binomial is 5x plus 4, because these are both positive signs. This one does reduce. 5 goes into 5 one time, goes into 10 two times. So it's 1x plus 2, or we'll just call it x plus 2. And if you want to FOIL this out, you'll find that you end up with this equation, okay? 5x times x is 5x squared. 5x times 2 is 10x. 4 times x is 4x. 10x plus 4x is 14x right there. And 4 times 2 is 8 right there. So this does work. Okay, so still not at our final answer yet. Okay, so what I'm going to do is I'm going to come down here. And I'm going to take this. And don't forget this. This is also a factor. We verify that by dividing it into this using synthetic division and coming out with no remainder. So that means this does factor out evenly out of this number. So we're going to go ahead and put that right there. Okay? So those are all of our factors. You can't factor any of these anymore. So now we're going to set this equal to 0. And we're going to figure out what makes each of these terms go to 0. So the first one's really easy. It's going to be 2. 2 minus 2 is 0, so 2. This one's going to be easy. Negative 2 plus 2 is 0, so this one's negative 2. And this one is, we're going to have to do what we did on the last problem. Let's come over here and just do a little equation. 5x plus 4 equals 0. What value of x makes that happen? So we subtract 4 from both sides. These cross out. You end up with 5x equals negative 4. Now I'm going to divide both sides by 5. These cancel, and so I have x equals negative 4/5. So this answer is going to be negative 4 over 5. Okay, you put negative 4/5 in for x, this will go to 0. So these are our answers right here. The x equals this, this, or this, or this. It doesn't have to be all three. It's just any one of those. So again, what does that mean? If you took any of these three numbers and plugged them into this original equation up here, you'd end up with 0. Okay. All right. Let's go to number 6. Okay, I'm running up against my time limit, so 6, 7, 8, and 9 I'll do on a second video, so this will get you started. This is mostly what we did in class. So go ahead and do these, and this is actually number 6, not number 9. So go ahead and do 6. Go ahead and do the ones that I've just done. Be sure you know how to do those, and I'll continue this on the next video.